So last class, I kind of left you on an edge when I told you that when I explained all that sort of, like special factorizations and regular factoring. But then I told you, after all that, some equations you can't do that with some equations. So let's actually review a little bit of what we did last class with this problem, a special factorization problem. Well, this, instead of taking this through the whole, factorization machine, we can just say that this is x squared plus 2 times 2 times x plus 2 squared is equal to 0. So this whole thing here is just the square of x plus 2, and it's kind of awkward writing like this because lefty. So this is x is -2. So we're using that. What if, say, I had the equation x squared plus 4x plus 3 equals 0? What if? Let's solve this. So, well, we can still see that this is x squared plus 2 times x plus 3 is equal to 0. But there's one little problem. We see, because there's, instead of plus 4, it's not plus 2 squared. This isn't 4, it's a 3. So then what we do? Well, this method here is called complete the square. We're completing the square. So, well, basically, all that says is that we have part of a square. Well, you can't do anything with part of a square, so we complete that square. So if we have x squared plus 2 times x, well, then we can just add on 2 squared. But then, of course, you can't play favorites. If you add on 2 squared, you have to subtract off 2 squared too. And we still have the plus 3 equals 0. So now we basically completed the square, because this thing right here, this little thing that I bracketed up, is the square of x plus 2. Then you have minus 4 plus 3 equals 0. And we have x plus 2 squared minus 1 equals 0. And okay, it's kind of a little slow here, but yes. The square of x plus 2 equals 1, and taking the square root of both sides, x plus 2 is equal to plus or minus 1, and subtracting 2 of x equals plus or minus 1 minus 2, so we either have x is equal to positive 1 minus 2, which is -1, or x is equal to negative 1 minus 2, which is -3. So, equals x is equal to -3. So, was kind of a little jump start on this next problem, which is basically pretty simple. I think we just cut it off here, and then we solve this. So I don't even think I really need to go over this, or just do a quick little explanation on this. Equals 12. I just added 12 to both sides, and dividing by 3, I have the square of x plus 1 equals 4, and then taking the square root of both sides, we have x plus 1 equals plus or minus 2, because it's the square root. And then subtracting 1 from both sides, we have x is either positive 2 minus 1, which is 1, or we have x is equal to -2 minus 1, which is equal to -3. And don't think I borrowed that problem from here. So now what we can look at is this problem, completing the square of this. Now, a quick little note here. Yes, here we have this little negative of a. Now this completing the square method only works when this a coefficient is 1. And I'm not kidding, okay? It's not just that it's easy, it's the only way that completing the square works. So instead, here you have to take out a factor of -5. So Well, here, I made the problem kind of nice and convenient so that you have whole numbers like this. But even if it is something like this, I'm gonna use blue pen just to make sure that you can see it. Even if it is negative 5x squared plus 10x plus, say, 4 is equal to 0. And then you really don't want to take out the factor of negative 5, because then you see that minus 4 over 5 here. Oh, newsflash, you're going to have to do that, because completing the square only works only works when a is 0. And that's one of the reasons why, only works of 1. So, and that's one of the reasons I taught this after factorization, because of course you would always, of course, rather do factorization than completing the square, number 1, because of this, and number 2, just kind of long to do it. And well, next class, we're going to use completing the square to do something rather more cool.